The twin tube shock absorber is a shock absorber made with two coaxial tubes. Doesn't matter if it is a standard McPherson with standard stirrups or a McPherson with stirrups that are not conventional, or if it is a cartridge, or if it is a conventional shock absorber. All of them are twin tube shock absorbers. They are twin tube shock absorbers because they are made with two tubes. The external one that we will call body, this, or this, or this, or this. The internal tube that we will call cylinder, this is very thin, it's difficult to appreciate it, and this. Then we have the rod, okay? This is a hollow or empty rod, the rod, the piston, including one valve. Then there is the guide. The function of the guide is to guide the rod along the cylinder and to guide the cylinder along the body. Then there is the bottom valve. The bottom valve is another valve that connects the cylinder with the body. In all of them, we have oil and gas. Gas could be nitrogen or air, and doesn't matter. And the pressure of the gas could be 1 bar, so the standard pressure or more. In the proper and right conditions, we will have that the inner cylinder or the cylinder is completely full of oil. It must be full of oil, above and under the piston, always full of oil. The chamber around the cylinder into the body must be full of oil during 50% or 3/4 of the body with the rod in. I repeat, with the rod in, the outer cylinder must be full within the half or 3/4 of the cylinder. Depends on how much big is the rod in comparison with the diameter of the cylinder. But this is a detail that we will see later with the practice. So, how a dual tube shock absorber works? Again, it's better to see in detail how the piston is made. It is very similar to a monotube piston, so we will have some holes. Holes are closed by shims. Shims could be preloaded because the shape of the piston or because additional springs. Then the bottom valve is similar to the piston, so we will find certain holes working in rebound and compression, and these holes are closed with shims that could be preloaded. In both cases, we have bypass, shims, etc. Let's see how it works. Suppose that I press the rod in, so we are working in compression. I create a pressure in this area and a vacuum, so a pressure between the piston and the bottom valve, and a vacuum between the piston and the guide. Because the difference of pressure, the oil is forced to cross the piston and to cross the bottom valve. The as you can see, this volume is higher than this volume, because in this volume there is included also the rod. So what happens? That an amount of oil equivalent to the volume of the rod that goes in crosses the bottom valve going into the chamber, while a volume of oil equivalent to this volume less the volume of the rod crosses the piston. Okay? Piston is crossed by oil in compression as well as the bottom valve. So both are working in compression. During the rebound, I'm pulling out the rod, so I create a pressure between the guide and the piston, and a vacuum between the piston and the bottom valve. Because there is difference of pressure, the oil is obliged to cross the piston and to come here. For the same reason, the oil that is in the chamber crosses the bottom valve, coming here too. So we can say that when the rod is pulled out, a volume of oil equivalent to the volume of the rod that left the shock absorber comes from the chamber, crosses the bottom valves, and comes here. While a volume equivalent to this volume, a volume of oil equivalent to this volume less the rod is passing from the top to the bottom through the piston. So again, we see that piston and bottom valve are working also in rebound. Now, at this point, we have to tell the main rule, the golden rule of dual tube shock absorbers. The golden rule of twin tube shock absorbers is that the bumping force of the piston in compression must be always lower than the bumping force of the bottom valve in compression. I repeat in a simplest way. In compression, the piston must be softer than the bottom valve in compression. I repeat. The piston in compression must be softer than bottom valve in compression, or vice versa. The bottom valve in compression must be always harder than piston in compression. Why? Because suppose that the shock absorber, that valves are adjusted in order to comply the golden rule. It means that here we have a big bypass and here a small bypass. Suppose that into the piston we have soft shims working in compression, and in the bottom valve hard shims working in compression. So suppose that our piston in compression is softer than the bottom valve in compression. Now suppose that I push the rod in, so I work in compression. Working in compression, I create a pressure here, a vacuum here, so the oil is obliged to cross the piston and the bottom valve. We have also to keep in mind that oil is a little bit, let me say, lazy, and is always looking for the easiest way. If the piston is softer than the bottom valve, for sure the oil will cross first the piston. Then once this chamber, the chamber between the piston and the guide, is completely full of oil, then the oil will be forced to cross also the bottom valve. In this way, we are sure that the chamber between the piston and the guide is always full of oil. And this is a big advantage because in rebound, when we pull the rod out, for sure, between the piston and the guide, there will be oil. Only oil, just oil. So it will work properly in rebound too. Okay? Now, suppose that for any reason the piston in compression is harder than the bottom valve in compression. What happens? Happens that in compression, when I push the rod in, the pressure obliges the oil to pass through the piston and the bottom valve. Remember that the oil is lazy, so we'll try to pass where it makes less effort. If the piston in compression is harder than the bottom valve in compression, the oil will pass through the bottom valve. Passing through the bottom valve, here a vacuum will appear, and we will absorb the cylinder above the piston will absorb air or gas from the top. It means that later, after the compression, when working in rebound, between the piston and the guide, there will be first air, then oil, and the piston will be pulled up, compressing first air and then oil. Air creates any resistance, so we will have a shock absorber that in rebound makes any resistance. Within the air between the piston and the guide escapes, and at this point it starts working. But what happens? Happens that instead of having a nice diagram in compression and in rebound, we will have a diagram like this. So it works properly, or more or less properly, in compression, but later in rebound, because working pressing the air, we see that we have any bumping resistance. Within we arrive here, air is escaping, and finally it starts working properly. But we understand that this means that it's not offering resistance first. So the shock absorber will be very soft in rebound. But the second problem is that when we arrive here, the oil will shock against the guide between the piston and the guide, and will be a shock, will be a vibration. And this will create noise. And vibration and noise will be transmitted to the car through the frame, amplified, and you will hear a knock, 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 a metal noise. Your feeling will be that the bolt is not properly screwed, but it's not that. It's the oil that is shocking against the guide. For this reason, it's mandatory that the piston in compression must be softer than bottom valve in compression. Now, the question is, how is possible when doing a twin tube shock absorber to understand if the piston in compression is softer than the bottom valve in compression? And in which cases can happen a mistake, and that can create troubles. This is the question that we have to have always in mind. And we will answer to this question later after explaining in detail how piston and bottom valve on dual tube shock absorbers works, because in this way it will be easier to understand how the problem appears and how to solve it. Just 1 minute, please. Thank you.